Finally, let's look at exponential change. So what an exponential function looks like is it has the variable in the exponent. So y equals 2 to the x power is exponential, or y equals e to the negative x, or y equals 5/3 to the negative 3x plus 2 power. In all of these, the independent variable x is in the exponent. Let's go ahead and complete this table, and then we're going to graph 2 to the x power. So with an exponent of negative 3, remember that exponents that are negative, think of them as repeated division instead of repeated multiplication. So instead of this being 2 times 2 times 2, this is 1/2 times 1/2 times 1/2. Works out to be 1/8. So 2 to the negative 3 power is 1/8. 2 to the negative 2 power is the same thing as 1/2 times 1/2. Or we could also think of that as 1/2 squared, which equals 1/4. 2 to the negative 1 is 1/2. 2 to the 0, don't say 0, 2 to the 0 is 1. Anything to the 0 power equals 1. 2 to the first equals 2. 2 squared equals 4. 2 to the third power equals 8. Here's what that looks like. There's a graph. So I can see that as x increases, y increases at a faster and faster rate. So let's look at the difference between these changes on this table that we built. This might be a little bit weird with the fractions. We could do it with the fractions, but let's start at the whole number. So let's start from x equals 0 on. So I see the change from 1 to 2 is a change of 1. From 2 to 4 is a change of 2. From 4 to 8 is a change of 4. And from 8 to 16 is a change of 8. So these numbers are not constant, but there's certainly a pattern there. 1, 2, 4, 8. 1, 2, 4, 8. I can guess that the next increase would be an increase of 16. So 16 plus 16, I am running out of room here, but 16 plus 16 is 32. So continuing our table here, x, y, so this was 4 and 16. So I'm guessing that that next change would be a change of 16, increasing this by 16. That means we end up at 32. And sure enough, if x is 5, 2 to the 5th power equals 32. This is pretty cool. Let's see if it holds true for another exponential function. So y equals 3 to the x looks very similar to the first graph. If anything, it just goes up all the faster. All right, looking at the change. Again, I'm going to kind of gloss over the fractions. Let's go with the whole numbers. So this is an increase of 1 to 3. That's an increase of 2. This is an increase of 6. Gosh, what is that? 18, right? Yep. And then 81 minus 27 is 54. So these numbers, 2, 6, 18, and 54, are not represented in the table. Or are they? Think about this like this. I notice that all of these are even. What if I wrote them as 2 times some number? So this first one is 2 times 1. The second one is 2 times 3. This next one is 2 times 9. And the last one is 2 times, gosh, what is that? 25, 26, 27. I should have known it was 27 because looking at these numbers, 1, 3, 9, and 27, are right there. At this point, you may be looking at the video and saying, geez, Megan, I am not going to be able to spot that. How do you expect me to do this? So there's another way of figuring out if a table represents exponential data. And that other way is looking at the percent change going from one number to another number. So we've been thinking about this as looking at the change always as an additive change. I go from 1 to 3, that's a change of 2, because 1 plus 2 equals 3. 3 plus 6 equals 9. So if we think about this as a multiplicative change, because think about how we build the table. We built it, I guess we built y equals 2 to the x, not 3 to the x. But thinking about this, when x increased, what we did, whoops, it's 1. When x increased, what we did is we just multiplied in another 3 each time. 3 squared equals 3 times 3, which is 9. 3 cubed equals 3 times 3 times 3, which is 27. That's an equal sign. So really, the pattern here is more one of multiplication than addition. So for all of these, let me erase our previous work. For all of these, going from 1/27th to 1/9th, we really just multiplied by 3. Going from 1/9 to 1/3, we multiplied by 3. 1/3 to 1, we multiplied 1/3 by 3 to equal 1. We multiplied 1 by 3 to equal 3. 3 by 3 to equal 9. 9 by 3 to equal 27. And 27 by 3 to equal 81. So how can you tell if something is an exponential relation? 2 ways. The rate is determined by the current scale. So we found the pattern 1, 2, 4, 8 or 1, 3, 9, 27 in the changes, though it might be scaled. Or the percent increase is constant. We can multiply in by the base to find that pattern. Thank you.